Back when you were in Calculus 1, the first thing that you did after learning the definition of the derivative was probably to learn lots of rules about taking derivatives. So the product rule, the quotient rule, the chain rule, stuff like that. And so we just learned a new definition for differentiation, a particular type of differentiation of these vector functions. And so we should expect there to be a lot of rules that apply to differentiation of these vector functions. And so I'm going to present right now a bunch of rules that you should know about differentiation of these vector functions. And I should say this kind of sheet, these listing of rules is going to be a somewhat common thing in this class. Like each time that we have a new way to define a certain type of differentiation in this class, and there will be multiple ways of doing differentiation, we'll have this kind of listing out of all of these rules. Okay, so what's going on here? So let u and v be differentiable vector functions of t. C be a constant vector. So C is just composed of numbers. 1 times I hat plus 2 times j hat plus 3 times k hat, something like that. No t dependence. Little c here is any scalar, just like 5. And f is any differentiable function, any differentiable scalar function. So by that, f of t is equal to t squared plus 1. There's no I hat, j hat, k hat stuff going on here. So what are our rules? First off, constant multiple rules. Sorry, that shouldn't be constant multiple rule, constant function rule. My apologies. The constant function rule, take the derivative of a constant vector, and you should get the 0 vector. Not 0 the scalar, but the 0 vector. Okay, scalar multiple rules. If you multiply your vector function by a scalar, like 5, then the answer is just going to be that scalar times the derivative of your vector function, u prime of t. Now, if you instead multiply your vector function by a scalar function, you get a product rule here. So the derivative of f of t, the scalar function, times u of t, the vector function, will be f prime of t times u of t plus f of t times u prime of t. And so this should be very recognizable that this is a product rule going on here. The derivative of the first function times the second plus the derivative plus the first function times the derivative of the second. Okay, the next couple of rules here, we have a sum rule. So the derivative of the sum of u of t and v of t will just be the sum of their derivatives, u prime of t plus v prime of t. The derivative of the difference of two vector functions will simply be the difference of their the difference of their derivatives. And then next up we have more product rules, with a dot product rule and a cross product rule. And so once again, these rules would be what we should expect them to be. One function times the derivative of the other function plus the derivative of the first function times the second function, just like the product rule. But the product that is in there is going to have to be the appropriate product, the dot or the cross. So the derivative of u dot v is u prime of t dot v of t plus u of t dot v prime of t. The derivative of the first function times the second plus the first function times the derivative of the second. In the cross product rule, the derivative of u of t cross v of t is going to be the same thing, u prime of t cross v of t plus u of t cross product v prime of t. For the cross product rule, let me emphasize something as being very important here. order matters in cross products. So if you're used to, from Calc 1, being sloppy about which order you write down your functions when you're doing the product rule, that's fine in Calc 1. But here, because u cross v and v cross u are in general not equal to each other, we need to always have the u or u prime come first in the cross product, and the v or the v prime come second in the cross product. So make sure you always adhere to that rule. And then finally, for the chain rule, the derivative of u of f of t, take a function f of t and slide it into your u, is just, and so note here this f of t is a scalar valued function. It will be chain rule, so it is this right here. Let me just write this out. Take the derivative of the outside function u of t, leave the inside alone, as though it's f of t, multiply it by the derivative of the inside function, f prime of t. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8 rules here. Let's do a few examples using these. So the derivative of r1 of t dot r2 of t, I wrote up here, r1 of t is t squared t cubed t, and so on and so forth. So this will be derivative first function dot the second plus the first one dot with the derivative of the second. Okay, so the derivative of r1 of t would be 2t, 3t squared, and t, dot product with r2 of t, e to the 3t, e to the 2t, e to the t, plus r1 of t, t squared, t cubed, t, dot product with the derivatives here. So 3e to the 3t, 2e to the 2t, e to the t. And so let's write out this. So it'll be this times this, 2t e to the 3t plus this times this, 3t squared e to the 2t plus this times this, t e to the t plus this times this, 3t squared e to the 3t plus this times this, 2t cubed e to the 2t plus t times e to the t. Oh, I made one mistake. What mistake did I do here? I forgot to take the derivative of that t in there. So it's okay to make mistakes. It's okay to make mistakes as long as you can catch your mistakes here. So that should have been a 1 there. Sorry about that. Plus t times e to the t. So that is our first example here. By the way, let me just note here that r1 of t dot r2 of t, that's a r1 of t dot r2 of t, that's a scalar value function. The dot product of two vectors is a scalar. The dot product of two vector functions is a scalar function. So the derivative of this of the scalar function is a scalar function. There's no vectors here. The derivative of r3 of t, 1 pi e. Note here, those are all constants. So this is the 0 vector, 0, 0, 0. Okay, I think this is a good place to wrap up this video. We'll do a couple more examples of differentiation rules in the next video, along with prove one of the rules.